Hello students, my name is Sumit Mehta. So in today's lecture we'll start a new chapter named as Vector Algebra, and in this lecture we'll study about some basic concepts of vector algebra. Okay. So in a three-dimensional plane, let's say, okay, so there are, let's say this is a line in a three-dimensional plane. Let me draw a three-dimensional plane also. This is x-axis, this is your y, and the third one is the z-axis. Okay, so to represent a line in a three-dimensional plane, I can write this as x I cap plus y j cap plus z k cap. Okay, where x, y, z are the respective magnitudes in x-axis, in y-axis, and in z-axis. Okay, so to define the magnitude of the L vector, so this is L vector. Okay, so to define the magnitude of this position vector, you can say, so this will be x square plus y square plus z square. So this is the position vector L. Okay students, so in a three-dimensional plane it should be in I, where I cap denotes the position towards x-axis, where j cap denotes the position vector towards y-axis, and k cap denotes the position vector towards z-axis. Okay, and this denotes the magnitude or the length of vector. Magnitude or length of a vector. Okay, so to illustrate this, student, what I'll say is a term named as direction cosines. What are the direction cosines? It means, let's say this is L vector, okay, and this is making angle alpha with your x-axis, beta with the y-axis, and the gamma with the z-axis. Okay, so what are the direction cosine in each direction? Okay, means the angles, what I have written here, the angles alpha, beta, and gamma made by vector L, okay, with the positive directions of x, y, and z axis respectively. X, y, and z axis respectively. Okay, so these are called direction angles, and these are called direction angles, and the cosine of alpha, cosine of beta, and cosine of gamma are called as direction cosines. Okay, so now I hope that you guys are pretty clear about what is direction cosine. Okay, and there is one more term named as direction ratios. Okay, so direction ratios are, student, these are expressed at the numbers. Let me tell you, students, these cos alpha, cos gamma, cos beta are also called as L, M, and N. Okay, so if I write this, if I make a, like, this is a 90-degree here, 90-degree here, and if you drop a 90-degree here from this point, let's say this is 90-degree, so cos alpha will be your x by L, where L is the length vector this. Okay, cos gamma, cos beta will be y by L, and cos gamma will be z by L. Okay, and these are called as L, M, and N. Okay, let's say, let me give it a new name, R, radius vector. Okay, so to not to confuse with this L, so this is, and the direction cosines are these terms. Now we need to define the direction ratios of vector, this vector R. Okay, these are denoted by A, B, C, where, and the numbers, like if this is uh, as you know, x by R is equals to L, so R, LR, LM, LR, MR, and NR respectively denotes A, B, C, and these are called as direction ratios. Okay, so once again I am restating it. The LR, the term x is equals to LR, so this is the direction ratio in x direction, this is the direction ratio in y direction, and this is the direction ratio in z direction. So these are denoted by A, B, C, and the relation between direction cosines is L square plus M square plus N square is equals to 1. Okay, this is in general, but A square plus B square plus C square is not equals to 1 in general. So these L, M, and N are direction cosines, whereas A, B, C are direction ratios. Okay, so I hope students now you are pretty clear about what are direction cosines and what are direction ratios. And in the next lecture, we'll discuss about types of vectors.